Yeah, once again, good morning to everyone. In the last week, we were discussing about the overtaking side distance, how the overtaking side distance are there, and what are the three major components D1, D2, D3, how it can be estimated that we have seen as problems. Followed by we started about the super elevations, why we are providing the super elevation. So the super elevation is nothing but, as I told, that the outer edge of the pavement is raised with respect to the some ratio with respect to the center line of the, what we can say, the road. So this can be calculated with respect to the E into B. So B is nothing but the width of the road, that E is nothing but the super elevation, and this E is nothing but what will be the rise or the width we are providing. So the super elevations are how it can be estimated, E divided by D, which is nothing but the tan theta. So various factors are influencing to design the super elevations, like the speed, horizontal curve, radius, what we were provided on the field, then the coefficients of frictions between the tire as well as the road surface, the pavement surface, and the center of gravity. So with respect to all the factors, also the F is nothing but coefficients of the lateral frictions, which has a limit of 0.15. Also, the super elevation having a different kind of the value, maximum value with respect to the plain and the rolling terrain, hilly roads, and the urban road. Also, we are providing the minimum super elevations by considering the chamfer value, which is usually we provide for the rainfall drainage from the pavement surface. In addition to that, we started and we tried to understand how to design the super elevations for the given problem. So four step of the problems we have discussed in the last class. What we assumed in the sense, we assumed that the frictions which we are trying to achieve 75% from the design speed, if there is a no specifications and the frictions between the tire as well as the pavement surface are existing. So the formula is modified as 0.75 into V. Overall, we are getting E is equal to V square divided by 225 into R. When you know the speed and you know the radius, accordingly you can able to estimate what will be the super elevations value. The next step, what we are doing in the sense, we know that IRC is permitted the maximum super elevations value as an 7%. If it is exceed more than 7%, then we are restricting with the 7% alone. Example, I shown that if 0.03, then it is 3%. It is accepted, which is ultimately less than 7%. But when it is coming to the 13%, it is more than 7%. So we have to provide the super elevation as an 7%. When we are finalizing this kind of the 7% as in a super elevations, we should know what is the frictions value. So that frictions value is reflected in the term of the coefficients of the frictions in the equation. E plus V is equal to V squared divided by 127 into R. So this is in a typical equations. You apply 0.07 V value, R value. You come to know what will be the F value. As I mentioned that the F also having the maximum value, permissible value, which is nothing but 0.15. If it is less than 0.15, it's not an issue. If it is going to more than that, then you are fixing the maximum value as a frictions value at that particular design problem. So the E value, F value is defined by us with the permissible maximum value as per the IRC. So the fourth step, what it is defined in the sense, we have to revise the equations by considering the E value and F value, and to estimate what will be the revised design speed, That design speed we have to propose for the design problem. Initially, we might be started with 100 km per hour, but after following the 4 steps, finally it is reducing to the 80 km per hour. So this is in a conclusions. We are getting the 4-step design problem. Probably we can try to solve the problems one by one. So definitely you come to know the clarity about the 4-step problem. So this is in a problem 1. In the problem, a 2-lane road is aligned with a horizontal curve of radius 360 meter. The design speed is 65 km per hour. What is the rate of super elevation is introduced by rotating about its center line? By how much should the outer edge be raised the middle? The pavement width is 7 meter. So what they're telling in the sense, they given the radius of the horizontal curve R is given. The design speed V is given. They were asking if you are providing the super elevations E, then what will be the rising value? So example, so this is the rise we are providing with respect to the center line. So they have mentioned that the pavement width B is equal to 7 meter because this is a 2-lane road. So they have given the 7 meter. Then basically the rising with E equal to, what is the equations? E into B. So this B is nothing but the super elevations. B is nothing but E is super elevations. B is width of the pavement which is provided on the problem. So first you have to estimate the super elevations value. So the equation is E is equal to V squared divided by 127 into R. Okay, but we have defined with respect to the 75 percentage, right? So the equation is ultimately changing to 25 into R. So when you're trying to apply 65 square divided by 225 into R is nothing but 360 degree. So you will be getting what is the super elevations, the rate of super elevations, what we are providing. Then we have to check the limitations. So whether this value is less than 0.07 or greater than 0.07. If it is less than 0.07, you take it as it is. If it is more than that, then what you have to do, you have to finalize your value 0.07. Then you have to go for the step 7. So let us solve this problem. 65 square divided by 225 divided by 360. So I am getting the value of 0.05216. So probably we can fix it as 0.05 or 0.052. So this is a value which is ultimately less than 0.07. So this E value is acceptable. There is no need of following the step 2. But the question is not super elevations. How much should the outer edge be raised the middle? So with respect to the center line, how much rise we have to provide? So the rise is nothing but capital E is equal to small e into B. Small e is nothing but 0.052 into 7 meter. So the rising, how much meter we have to provide? 0.052 into 7. So 0.364 meter I am getting a value. So this is an E value. So this is the rise we are providing with respect to the center line to introduce the super elevation. That super elevations ultimately neglecting the effect which is provided by the centrifugal force. The centrifugal force basically it introduce or it cause over skidding, okay, skidding or overturning. So these two issues happen due to the centrifugal force which is ultimately happen with respect to the loss of the friction and the super elevation. So to avoid all this conflict and the accident, the super elevation is introduced on the field. So this is one simple problem how we are providing the super elevation. Then the next problem, design the super elevations for a highway curve of radius 480 meter for a design speed of 100 km per hour. Use the recommendations of IRC values wherever it is necessary. So they were simply asking what is the super elevations value when the radius is 480 meter and the design speed is 100 kilometer per hour. So this is the two things they have a given for the mixed traffic conditions for the Indian scenario. So the equation is, we know that E is equal to V squared divided by 225 into R. So V square is nothing but 100 square divided by 225 into 480 meter. So what is the E value we are getting? 100 square divided by 225 divided by 480. So I am getting the value in the calculator 0.09259 etc. 2592 I am getting. So approximately we can fix it 0.093, which is greater than 0.07. As per the IRC, for the Indian conditions, I told that the 7% is the maximum permissible value. So step 1, we estimated E value. Step 2, we are comparing with respect to the 7%. So it is exceed more than 0.07. So we are finalizing the E value as an 0.07. So this is in a super elevations we are providing with respect to the radius 480 and the speed 100. But when we are not providing as per the design value, we are provided with respect to the IRC recommendation. So the F value need to be revised or rechecked. So E plus F is equal to V squared divided by 127 into R. So this is an equation. E is 0.07 and F we are going to estimate. Then the 100 square divided by 127 into R value is nothing but 480. So what will be the F value? 100 square divided by 127 divided by 480. So I am getting the value of 0.16404. So I am just finalizing 164 minus 0.07. So we are getting the value for the F 0.094. The maximum permissible value is 0.15. So this value is ultimately less than the maximum permissible value. So we can adopt the F value as 0.094. There is no need to go for the step 4. Step 4 is nothing but reversing the design speed. So this is in a simple calculations for the given curve of radius 480 meter, the design speed 100 kilometer. We are estimating what will be the super elevations value. So we know the equations V square divided by 225 into R. While applying, you are getting the value of 0.093, which is greater than the permissible value of 0.07. So in the step 2, we are finalizing the E value as 0.07. Since we finalize the maximum super elevations value, we should check what is the value for the coefficients of lateral friction. So the lateral frictions, the equation is E plus F is equal to V squared divided by 127 into R. You apply the E value as 0.07, V as 100, R as 480. Finally, you are getting the F value of 0.094, which is less than the maximum permissible value of 0.15. So this is the acceptable value and the acceptable design standard for the given problem. So this is another way how to estimate the super elevation. In continuation of that, the same concept, we can go through the next problem. Determine the radius of horizontal curve beyond which no super elevation is provided for a design speed of 65 km per hour on a state highway. The chamfer is 1 in 40. So what they were asking in the sense, the radius, horizontal radius R value they are asking. So what is the R value when we are not providing any super elevations, but we are providing the chamfer value as a 1 in 40 for the design speed of 65 km per hour. So cross slope only we are providing, so that can be maintained as a super elevations also to drain the rain water also. So the problem R value they were asking, the given parameter is nothing but V 65 km per hour, E they have a given 1 in 40. So 1 in 40 is 1 divided by 40. So you will be getting the value of 0.025. E is equal to 0.025. So you know the E value, V value, what is the R value that you have to estimate. So you know the equations, E is equal to V squared divided by 225 into R. So E is nothing but, maybe you bring R here, then V squared divided by 225 into E. Then apply speed 65 squared 225 into E is nothing but 0.025. So finally you will be getting what will be the radius. So if you are applying 65 squared 225 65 squared divided by 225 divided by 0.25. So I'm getting the value of 751.111 I'm getting. So approximately I'm fixing the 751 meter as an radius. So hope this is a simple problem you might be getting. They were asking to estimate the radius of the horizontal curve with the condition of there is a no super elevations provisions is provided for the design speed of 65 km per hour on a state highway. But the provided the chamfer value or the cross slope is 1 in 40. So that slope is considered as a super elevations for the designing the horizontal curve. So V is nothing but 65. E is 1 in 40, 1 divided 40, you will be getting the value of 0.025. Then you know the equations for the super elevations. You try to apply the value of V and E, then you will get the value of the radius 751 meter. So this is the things we are providing on the field as an radius of the horizontal curve with the design speed of 65 km per hour and the chamfer of 1 in 40. The next problem, so where we try to follow all the 4 steps. Okay, the 2-lane highway, they have again consider the design speed is 80 km per hour, which is aligned with respect to the horizontal curve radius of 180 meter. What is the super elevation is required to maintain this speed? So they want to maintain this particular speed. They were asking what super elevations we have to provide. If the maximum super elevations rate of 0.07 is not to be exceed and the radius cannot be increased beyond this, what is the allowable speed? So that they were asking. What they are explaining in the sense, the super elevation is increasing the value of 0.07, but we cannot provide that super elevation. We have to fix the super elevation as an 0.07. When we are trying to fix 0.07 as a maximum super elevation, We cannot revise the 180 meter. So 180 meter is a fixed one. In that condition, what will be the revised speed? That they were asking what is the allowable speed if we are fixing 0.07. Also, they given the criteria, the coefficients of lateral or the transverse frictions coefficients cannot be exceed 0.15. So these are the criteria they have given, even though they were not giving this three lines. It is default, you have to assume these three lines. This is a standard one. Okay, let us solve step one by one. First, we estimate. They are asking what is the super elevations required to maintain the speed. So super elevation step 1, we are estimating E is equal to V square divided by 225 into R. In the problem, V is 80, R is 180. So V square 80 square divided by 225 into 180. So you can apply this value, 80 square divided by 225 divided by 180. So I am getting the value of 0.158. So this is in a super elevations which we got it from the equation, but we know that step 2, the E is maximum allowable value is 0.07. So this value is greater than 0.07, which is not able to adopt on the field. So in the step 2, we are comparing and we are telling that the E is to be limited the value of 0.07. So we have a limited the value of super elevation, then it is highly needed to recheck the lateral coefficients of frictions value. So that is considering as a step 3. So the equation is E plus F is equal to V square divided by 127 into R. The previous problem we have seen, right? So F is equal to V square divided by 127 into R minus E. So V square is nothing but 80 square divided by 127 into radius is 180 meter. Then the super elevation is 0.07. So what value we are getting? 80 square divided by 127 divided by 180. I am getting 2799965 minus 0.07 is equal to 0.2099 I am getting. So I am assuming 0.1. Then the problem itself, they have mentioned that the transverse frictions coefficients cannot be exceed 0.15, which means that I told that this value is permitted with respect to the maximum value of 0.15, but it is exceed more than 0.15. So we cannot adopt this value. So finally, we are fixing the F value as a 0.15. So this is in a value we are finalizing for the super elevations and the lateral frictions coefficient. So the maximum super elevations we were not followed as per the design. It is revised and finalized with respect to the IRC standard. Then the problem itself, they have told that they cannot revise the radius. So we have to permit the speed of the vehicle on that particular road. So what we are doing in the sense, the step 4, we have to re-estimate what is the allowable or the maintainable speed on that particular stretch. So the equation is, we know that it is simple. Everybody knows that E plus F is equal to V squared divided by 127 into R. So 0.07 plus 0.15 V squared, we are going to estimate allowable speed 127 into R is nothing but 180. So you can estimate what is the value of the VA. So 0.07 plus 0.15, I am getting the value of 0.22 into 127 into 180. Root of answer when you are putting, so I am getting the value of 70.929168. I am getting 70.912 meter, but we can say the allowable speed is 71 kilometer per hour. So this is a final outcome. So this is the 4-step problem where we are following for the given the radius or 180 meter, then the design speed is 80 kilometer per hour. Super elevations we were estimating, it is more than the permissible value of 0.07. So we cannot permit this value. So the super elevation is fixed as 0.07. Accordingly, we have to estimate what will be the lateral coefficients of friction. While we are estimating the value, it is exceeding the maximum value of 0.15. So we are fixing the F value as an 0.15. When you are fixing E as an 0.07, F as 0.15, what will be the allowable speed? We are applying all the values. We are putting the VA is a 71 km per hour. So ultimately this 80 km is revised to the 71 km per hour. So maybe you put the speed limit board or the speed breaker or the variable sign board. So these kind of the remedial measures we can provide on the field, and we can inform the driver to maintain the speed of the 71 meter. So this is one problem to allow all the 4 steps. Probably this kind of the particular problem we can expect in your exams. Okay, not in this including this semester exams. You can expect for the many competitive exam. So most of the gate exam. So 4 step we have to follow for estimating the super elevations. So this kind of the typical problem we can able to see in the same directions. So little bit different directions they can ask the questions in your competitive exam. So like the design speed of the highway they given us a 50 kilometer per hour. So V is 50 kilometer per hour. The radius of horizontal curve R is 90 meter. The design coefficients of lateral frictions, this is F value is given. What is super elevation needed if full lateral friction is available? Basically what our super elevations equation means that EV square divided by 225 into R, right? So here we are assuming that 75% only we were achieving with respect to the coefficients of the frictions. Accordingly we were estimating, but here they given the full lateral friction is available, which means that F directly they given 0.15. So according to that, the equations we are following this standard and the typical equations for the super elevations estimation. E plus F is equal to V squared 127 into R. So E is equal to V squared divided by 127 into R minus F. As I mentioned that full lateral friction is available, so there is no need to assume 75% in the design speed. So V squared is nothing but 50 squared divided by 127 into 90 minus 0.15. So this is an E value you are getting. So 50 square divided by 127 divided by 90 minus 0.15. I am getting the value of 0.06872. I am just assuming 0.69 and the standard value is 0.07. So it is less than 0.07. Okay. So we can finalize the super elevation is 0.069 when we are considering the full lateral friction is available in the highway for the design speed of 50 km per hour and the radius of 90 meter. So this is a one thing's first problem. In the same data, they were asking what is the coefficients of frictions needed if no super elevation is provided, which means that the same equation, the E value become a 0, then what will be the F value? Right? It is very simple to calculate. The second one, E plus F is equal to V squared divided by 127 to R. E becomes 0. F we are going to estimate. V squared is nothing but 50 squared 127 into 90. So the F value is 50 squared divided by 127 divided by 90. So 0.218 I am getting 0.22 is the coefficients of frictions we need to provide if there is a no super elevation is considered. So this is with respect to the second problem. Then the third one, what they are telling in the sense, what is the equilibrium super elevations if the pressure on the inner and outer wheels should be equal? Okay, so the same conditions only, what they are mentioning in the sense, inner and outer wheels pressures are equal, the friction is nullified, so they are telling that the friction is become a 0. What will be the super elevations value? The same equations you apply F as a 0, and when you are estimating the E value, obviously the E value is coming the same, right? 0.22 only it will come. So this is a third solution. So here you see in your competitive exams what they have a given. So according to that you pick the three answers will be there in the reverse or wrong way they might be given. So according to that you have to finalize it. So this is one competitive exams they were asked with respect to the design speed and the radius, what will be the super elevations if full lateral friction is available when you are providing the 0.15. At the same time, there is a no super elevations. What will be the coefficients of friction? The next, if there is a no coefficients of the friction, estimate the super elevations value. So this is the way they have given the problem. So slightly it is very simple if you know and if you remember all the four steps. It is very simple steps. Only one equation is given, but with respect to the different assumptions, the four steps we were followed. So you might be asking the questions. So why the all the super elevations are in the positive? Yes, definitely the negative also you might be getting the value or the problem it might be given. So for the understanding purpose, so one more problem I have a given. If we are providing the negative super elevations, it was with respect to the terrain type of your road. So different kind of the terrain type is there. According to that we can able to provide, particularly the hill stations and all. So what they're mentioning in the sense, the minimum radius, determine the minimum radius of the curve, or they were asking determine the minimum radius of the curve for the design speed of 65 km per hour, and they are assuming F value as a 0.07, E value as a -2 percentage, but the calculations purpose 0.02 we are taking. So this is the things given in the problem, and your equation is nothing but E plus F is equal to V square divided by 127 into R minimum. They are asking the minimum radius. So E is nothing but minus 0.02, F is 0.07. If the F is not given, then you can assume 0.15. Okay. V is nothing but 65 km per hour, 127 into R minimum. Then what will be the R minimum value is equal to 65 square divided by 127 divided by minus 0.02 plus 0.07. I am getting the value of 665.3543. I assume 0.35. So the minimum radius can be provided as a 665 meter. So you just check it, the problem 665 or 666 given. So according to that, you can finalize it. So this is another way the radius can be estimated with respect to the given design speed and that assumed lateral coefficients of the friction and the super elevations rate what it is given, whether it will be a positive or the negative. Okay. So this is in a one way. So we can explain. So what will be the value? Yeah, in the same problem, example, if they are asking the super elevations in your problem, then it is fine. In case the super elevations rate, if they are asking, then this can be converted to the percentage and you have to tell it. Sometimes they might be telling us in a slope, so 1 in 100 or 1 in something. So in that particular point of time, so you have to divide, okay, 1 divided by when this e value we are putting, so you come to know what will be the value. So 1 divided by 0.069, I'm getting 14.49. So maybe 14.5 I'm assuming. So 1 in 14.5. So this is also sometimes they might be giving in the solution. So check in what way they have given 0.069 or 6.9 percentage or 1 in 14.5. So this three way they can replicate the value of the super elevation. So this is in a complete detailed knowledge about the super elevations. I'm sure that you will be getting a very good thorough knowledge for estimating and the designing the super elevation. Still the recorded video and the material I'm circulating in the group. So whenever you are getting a time when you are trying to recall it, so definitely you will be getting the better clarity. So any doubt from the super elevation estimation?
Yes, that's a small doubt.
Yeah.
So what does that mean? What is the equilibrium super elevation in the pressure on the inner and outer tire? That will you please explain that?
Yeah.
So
So
this will be
here what? Yeah. So here what they're telling in the sense the pressure on the inner and the outer wheels should be equal. So which means that there is a no frictions or the skidding effect are not happening. So it is nullifying. So basically, if you are talking about the last class and all, we have seen how the centrifugal forces are acting with respect to the pavement surface and the wheel. Due to that, how the issues are happening. To solve that issues, we are introducing the coefficients of frictions on the surface. So practically how we are giving in the sense the roughness we are providing on the pavement surface. So here what we are assuming in the sense the pressure is equal, which is nullifying. So when you are moving the outer or the inner side, the centrifugal force is nullifying. So when there is a no centrifugal force, then there is a no need to provide that coefficients of the friction. So that assumed that the F value was a zero value. So that is the way I have assumed and I have put it as a zero F.
Okay, sir.
Sir, I have a doubt.
Yes, please. Yeah.
Sir, when should we consider that design speed is 75% of the, I mean, the speed that we have to take is 75% of design speed. Like, when
No,
should we consider?
no, generally in the problem, F value is not given. Okay, you want to assume that F value, or they may telling that IRC standard is there, or there is a no specific kind of this problem if not given. So full lateral frictions are provided. So in that conditions, typically you have to estimate it. So there is a one way. So in the exam problems, when we are asking, so that is a way we have to assume it. Still, if we are not confident about it, the competitive exam and all, definitely you have the four options. You try to solve with respect to the four way and which one is matching, according to that you can finalize it. But whenever you want to assume 127 meter, so definitely they will be giving some criteria. So the full lateral frictions is available, or the pressure is equal, or you assume that F value was in a 0.07. So the F about the coefficients of frictions, something is defined in the problem, then you have to take this particular equation. If there is a no assumptions, or there is a no detail is given about the F, then you assume that 75% of the design speed, then the E value you can estimate, then you recheck your F value according to the problem.
Okay, sir. Thank you.
So yeah, SST problem we have a covered. Where is the lecture now? I'm just sharing the materials. So whenever you're getting time, you just go through it. So the next class, we will see the widening of the pavement, the next chapter. Basically, I have given the brief intro about the widening of the pavement. When the turning is there, the extra widening we are providing, particularly in the hilly stations we are providing. So it has a different component like a mechanical and the psychological widening. So how the definition is given, what is the typical equations, and with respect to the one or two problem we try to understand the extra widening on the horizontal curve. So the today class we covered the detail about that the details about the super elevation, the problems in unit 2 I'm just providing. OST problem we have covered, and the super elevations I mark it as an E. So this PDF I'm just sharing here. So any further doubts, student? Okay, OST problem plus super elevations I shared in this particular PPT. Then the SST also I have a given. So three major component we have a covered. So I request the students to go through once whenever you are getting time. So definitely one problem will be there, or we can expect two problem also from the unit 2 in your competitive exams. Okay, other than this theoretical, in this semester exams. So if there is no doubt, then we will wind up the today's session. Tomorrow we will start with respect to the widening. So thank you everyone. See you tomorrow.
Thank you.
Sure.
Thank you, sir.
Yeah, thank you everyone. I'm ending the section.